Internal ear. The internal ear is situated in the petrous part of the temporal bone, deep to the tympanic cavity. It is basically a closed system of fluid-filled intercommunicating membranous sacs and ducts which lie within complex intercommunicating bony cavities and canals. It consists of two parts, an outer bony labyrinth and an inner membranous labyrinth. Bony labyrinth. The bony labyrinth consists of a series of intercommunicating bony cavities which lie within the petrous temporal. It contains the membranous labyrinth and is filled with perilymph. It is about 18 millimeters in length. The bony labyrinth has three parts: cochlea, vestibule, and three semicircular canals. Cochlea. The cochlea is conical in shape and roughly resembles the shell of a snail. Its apex or cupula is directed laterally towards the medial wall of the tympanic cavity. Its base is directed medially towards the bottom of the internal acoustic meatus. It consists of a modiolus and a bony cochlear canal. Modiolus. This is an axial bony stalk around which the cochlear canal spirals. It is an elongated cone. The base of the modiolus lies at the fundus of the internal acoustic meatus. The apex is directed towards the middle ear. The apex of the modiolus is overlaid by the apical turn of the cochlear canal. The modiolus is perforated spirally at its base in the internal acoustic meatus by the fibers of the cochlear nerve. Cochlear canal. It is arranged spirally around the modiolus and makes 2 3/4 turns. Its basal turn bulges into the tympanic cavity as a promontory. Spiral lamina. This is a spiral bony ridge which projects out from the modiolar surface like the thread of a screw. The free edge of the lamina splits into upper and lower lips. The vestibular membrane extends from the upper lip of the lamina till the outer wall of the cochlea, while the basilar membrane extends from the lower lip of the lamina till the outer cochlear wall. This divides the cochlear canal into an upper part, known as the scala vestibuli, and a lower part, known as scala tympani. The scala vestibuli and scala tympani communicate with each other at the apex of the cochlea by a small opening called the helicotrema. The triangular area enclosed by the vestibular and basilar membranes in the outer wall of the cochlear canal forms the cochlear duct or scala media. Near the basal turn of the cochlea, the scala tympani presents two features: fenestra cochleae. These open into the tympanic cavity below and behind the promontory. Cochlear aqueduct. This is a narrow canal through which the perilymph within the cochlea communicates with the cerebrospinal fluid of the subarachnoid space through the cochlear canaliculus. Vestibule. The vestibule is a central ovoid cavity in the bony labyrinth and lies between the cochlea in front and the three semicircular canals behind. It is situated medial to the tympanic cavity. The lateral vestibular wall communicates with the middle ear cavity by the fenestra vestibuli, which in life is closed by the footplate of the stapes and annular ligament. The medial vestibular wall presents two recesses, a spherical recess in front and an elliptical recess behind. The two recesses are separated by the vestibular crest, which splits inferiorly to enclose the cochlear recess. The spherical recess lodges the saccule and is perforated by a foramina for the passage of the lower division of the vestibular nerve. The elliptical recess lodges the utricle and is perforated by foramina for the passage of the upper division of the vestibular nerve. Inferior to the elliptical recess, there is an opening for a bony canal called the aqueduct of the vestibule, which reaches the epidural space on the posterior surface of the petrous temporal. The vestibular aqueduct transmits the prolongation of the membranous labyrinth, the saccus, and the ductus endolymphaticus. The anterior vestibular wall bears an opening, which communicates with the scala vestibuli. The posterior vestibular wall has 5 openings for the 3 semicircular canals. Semicircular canals. There are 3 bony semicircular canals: anterior or superior, posterior, and lateral. They are situated in 3 planes at right angles to each other. Each canal is about 2/3 of a circle and is dilated at one end to form the ampulla. The anterior semicircular canal lies in a vertical plane at a right angle to the long axis of the petrous temporal. Its anterior ampullated end communicates with the vestibule anterolaterally. Its posterior non-ampullated end unites with the upper non-ampullated end of the posterior semicircular canal to form the crus communae, which opens into the vestibule. The posterior semicircular canal also lies in a vertical plane parallel to the long axis of the petrous temporal. Its lower ampullated end communicates with the vestibule and is innervated separately by a branch of the vestibular nerve. The lateral semicircular canal lies in the horizontal plane. Its anterolateral end is ampulated and lies close to the ampulated end of the anterior semicircular canal. Both the ends of this canal open directly into the vestibule. Thus, 3 semicircular canals open into the vestibule by 5 openings. Membranous labyrinth. The membranous labyrinth is a closed system of intercommunicating membranous sacs and ducts which lie within the bony labyrinth. It is filled with endolymph. It presents with a cochlear duct, saccule, utricle, and 3 semicircular ducts. The cochlear duct lies within the bony cochlea. The saccule and utricle lie within the bony vestibule, and the 3 semicircular ducts lie within the 3 bony semicircular canals. These 4 parts are interconnected in the following ways. The basal turn of the cochlear duct is connected to the saccule by the ductus reunions. The saccule and utricle are connected to each other by Y-shaped utricle-saccular duct, which expands to form ductus and saccus endolymphaticus. The utricle is connected to 3 semicircular ducts through 5 openings. The sensations from cristae, responsible for kinetic balance, and maculae, responsible for static balance, are carried by the vestibular nerve, while the sensations of hearing from the spiral organ are carried by the cochlear nerve. The cochlear duct is the spiral anterior part of the membranous labyrinth, with 2 3/4 turns. It lies in the middle portion of the cochlear canal, between the scala vestibuli and scala tympani. The cochlear duct contains the spiral organ of Corti, which is a sensory receptor for hearing. The structure of the cochlear duct is best studied in a cross-section of the cochlear canal. Boundaries. The base is formed by the osseous spiral lamina medially and the basilar membrane laterally. The roof is formed by the vestibular or Reissner's membrane, which passes from the upper surface of the spiral lamina to the wall of the cochlea. Laterally, the duct is bounded by the outer wall of the cochlear canal. Spiral organ of Corti. It is a peripheral organ of hearing and is located in the cochlear duct. It is situated on the basilar membrane. The important parts of the organ of Corti are as follows. Tunnel of Corti. It is formed by the inner and outer rod cells. It contains a fluid called corticolymph. The exact function of the rods in corticolymph is unknown. Hair cells. These are receptor cells of hearing, located on the basilar membrane. Their apices possess stereocilia, which are overlaid by the tectoral membrane. The inner cells are flask-shaped and are arranged in a single row, while the outer cells are cylindrical and are arranged in 3 or 4 rows. When sound vibrations pass from perilymph of the scala vestibuli to the perilymph of the scala tympani, the basilar membrane bulges and the overlying hair cells are stimulated. The inner hair cells are richly innervated by the cochlear nerve fibers and are responsible for transmission of the auditory impulses. The outer hair cells are innervated by efferent fibers from the olivary complex and are concerned with modulation of inner hair cells. Supporting cells, Dieter's and Hansen cells. The Dieter cells are situated between the outer hair cells and provide support to the latter. The Hansen cells lie outside the hair cells. Membrana tectoria. It is made up of a gelatinous substance and overlies the hair cells. Medially, it is attached to the osseous spiral lamina. The shearing force between the hair cells and the tectorial membrane stimulates the hair cells. Saccule and utricle. The saccule is a small globular membranous sac which lies in the anterior-inferior part of the vestibule. The utricle is an oblong membranous sac and is larger than the saccule. It lies in the posterior superior part of the vestibule. The saccule is connected anteriorly to the basal turn of the cochlear duct by the ductus reunions and posteriorly with the utricle by a Y-shaped utriculosaccular duct. The vertical limb of the Y continues as the endolymphatic duct, or ductus endolymphaticus, and its dilated blind terminal end is called the saccus endolymphaticus. The endolymphatic duct passes through the aqueduct of the vestibule in the posterior part of the petrous temporal. Its dilated terminal end projects onto the posterior surface of the petrous temporal, beneath the dura mater of the posterior cranial fossa. The utricle receives the three semicircular ducts posteriorly through 5 openings. Semicircular ducts. The three semicircular ducts, anterior, posterior, and lateral, lie within their respective semicircular canals. They open into the utricle by 5 openings. Each duct has one dilated end called the ampulla. The ampullary end of each duct has a raised crest, the crista ampullaris, which projects into its lumen. The peripheral receptors in the saccule, utricle, and semicircular ducts are as follows. Maculae. These are sensory receptors located in the medial walls of the saccule and utricle. They sense the position of the head in response to gravity and linear acceleration. This is known as static balance. Cristae. These are sensory receptors located in the ampullated ends of the 3 semicircular ducts. They respond to angular acceleration. This is known as kinetic balance.